Where does value accrues in robotic economy? I've been asked this question before. So let me start by saying there are 4 components, maybe 5, in what constitute a robotic AI. There's the hardware component, which is very commoditized, always be. So a lot of upfront costs, low margin, obsolescence, etc. The second one is the intelligence. Think about it, it's the software, the intelligent software that is, constantly updates within that box, that makes that box worth interacting with. Then there is actually the coordination, and I think that is actually the piece that is actually, so think about, so it's the multiple tasks in, for robots to do, or a fleet of robots. So we're talking about task coordination, you're talking about physical coordination, we're talking about, strategic coordination. I think that is actually the one that nobody's talking about. Everybody is focused on the hardware. And I think whoever owns that piece of that stack will really, it's sticky, it has the highest margin, because that, quite frankly, is pretty difficult, and it's pretty MOAT too. And there's the integration. If you integrate it within systems, it's very labor intensive, but obviously we're not gonna all of a sudden get rid of a system that has been built for human overnight. So you still in the beginning need to integrate it within a system of a sort. It requires a lot of expertise in deployment and operational knowledge, media margins, and then the last is the outcome, which is a result-based model. Think about it. It's like, this is the KPIs. These are key performance indicators that I, measure. And if you can prove to me that you can deliver better KPIs, then I will pay you this, or we can split, the savings, or we come up with something that is economically viable for you and I. Whoever owns outcomes, I think it's significant, and I think it's also high margin. So think about hardware, intelligence, coordination, integration, outcome. I love the coordination and the outcome. So the hardware is think about brick and mortars, right? Think about it as an example of owning real estate, right? I mean, you still have to. An example is, maybe real estate is already simplistic, owning a hotel. I mean, a hotel without without restaurant, without proper reservation system, without marketing, without, it's actually worth nothing, literally, right? You'd rather own, an apartment building. So hardware is very commoditized, and it's a lot of upfront costs, subject to obsolescence. Meaning somebody else gonna do it cheaper, more efficient, etc., etc. Think about a car, right? You buy a car, it's great design. In 5 years, you look at it, it's like, why did I buy it? You know why? It was great 5 years ago, not anymore. The intelligence, which is the software that makes the robotics, does what it does. So, like in any software, I think it's a high margin if you can have a mode of a sort, but that competitive advantage diffuses pretty fast. Let's put it this way, right? I mean, unless you become monopolistic, or unless you go very, very deep into a specific task of a sort. But usually it's, the only defense in any software is usually the margin that enables you to redeploy it and market it. So that's 2. 3 is the coordination. So the coordination is a robot on its own cannot do a lot of things, but it's the fleet of robots that together, the sum of these robots is greater than 5 robots is greater than 5, is what makes, the economics of robotic very interesting, because knowledge sharing, task amplification that, makes them, learn on a daily basis, coordinate. And I think that is significant. That's what the margin is. I mean, that's pretty much whoever owns that will literally dominate. I mean, think about Amazon. I'll give you an example. For instance, Amazon dominates in robotic. They don't do it, they do it for themselves, right? So not because they have the best robot, because they have the best orchestration system. They figured out, that's why they fired 30,000 people. That means they really figured it out, unfortunately, for those who got laid off. So that's the orchestration. You know, once they figured that out, they can get in a new robot and replace an old robot, because the knowledge and the orchestration is what makes them, sticky, what makes the warehouses efficient. Then the integration. The integration is, you take an old system and you try to plug it into a new system. And for those of you that are in businesses, think about, any automation that you use, right? But you build on an existing system. It's very fragile. It requires constant supervision. It requires patching of a sort, but it's necessary. It's part of the process. And then the outcome. The outcome, as I previously mentioned, I give you an example. Back to Amazon, not being paid by Amazon, by the way, is, do you care? The reason why we all shop at Amazon is because they deliver reliably on time. So that's pretty much, that's like a typical example of better integration and orchestration consumer facing, meaning from the time you press a button, the warehouse is clinging, the delivery goes into you within 24 hours. If you want to buy the same product from the original equipment manufacturers or the original brand, it will probably take you 3, 4, maybe 5 days, and you lose track and all of that. And that's pretty much what it is. So think about if somebody comes to you and said, "I'm gonna own the last mile," you don't care. You manufacture, I'll deliver, right? So you focus on acquiring customers and producing the widget, and I will do the rest. Pay me, and that's what the outcome is. And you're probably curious about how they're going to do it, but if a robot can do it better than your people, then yeah, I mean, reliably, then yeah, you want to take that, because switching costs is monumental. Number one, whether somebody is doing it for you or you kind of figure out yourself. 2, coordination is what makes robotics in general worth deploying. A robot on its own or a small fleet really cannot do much. So think about it. Going back to automation versus autonomy. In order for us to achieve autonomy, coordination needs to take place. Otherwise, if we just incrementally improve over tasks that are done by human for reliability's sake, they will probably choose human. If a robot can do it at 20% better than human, then you probably stick with human, because we're human and we trust each other versus robot. But then if 10 robots can do it better than 100 of your employees, and that can only happen not because each one of them has 20% output over a single individual, because together with the orchestration and the coordination, they achieve an output of 100 employee. That's where the value is. So robot on their own, without coordination, they use this. They're just a gadget. Just like humanoids, right? There's no coordination. They're independent, right? That's why they're limited. But it's the orchestration and the coordination that's make, robotic AI a think of the future. The reason why they were successful, because they did not incur meaningful integration costs, meaning they didn't use outdated warehouses and try to retrofit them, or try to not retrofit them and try to force a fleet of robots inside them. They probably did that in the beginning and they figure out, oh gosh, it doesn't work, or maybe it works, but you know what, a better idea is probably going forward, we need to think about the environment first. Let's design an environment that is predictable enough, that is modular enough, because things change, right? That where robots can do their tasks. And I think, remember, it took them a while. I mean, Amazon is not a new company anymore. So they've been at it for 20, 30 years, maybe 20 years, right? It's only recently they fired 30,000 people, and we are in 2026, right? So that's how long it took them to kind of really figure it out, to a point where they get rid of 30,000 people, period. So I think it's, the environment design that made them very, very successful in deploying robotics. And I think, other companies need to probably pay attention to that. We think about an input output. What's the input? So energy obviously is important. Productivity of a robot, integration cost, exponential learning, and coordination / orchestration. That is pretty much the function of every single one of them constitute the output of a robot economy. So let me repeat it again. So the output of an AI robot is a function of energy, uptime, the output, the integration cost within an ecosystem, and the coordination if you have a fleet of them. That is actually, think about it as the numerators. Think about it from a return on investment of a sort. So you have to divide that by, the cost, energy costs, coordination costs, maintenance costs, as well as the upfront costs to acquire the robot. And that constitutes the return on investment capital. And I think that's probably what everybody should be looking at, as opposed to using the old mental model about, output and, which is linear and, 24 hours and you're missing on the piece of the coordination. So a lot of people are now using the linear model. Oh, a human can work 8 hours, the robot can work 24 hours. And robot is 20% more productive. So they do the math and multiply by 20%, but they're missing on the cost associated with obviously the integration, because that's going to eat up at least 2 years. And then, the coordination, the orchestration, which I think is going to really bring up the J curve. So think about it as like you start here, dip a little bit, and then you go all the way up if you know what you're doing.